All right, continuing with our test here on Unit 10. So number 11 and 12. Number 11 says find the number of terms in this arithmetic series right here, and I have the two formulas listed. In terms of which one we want to use, it's going to be easier to use this one because they're telling us what a sub n and a sub 1 are, and you can see those are both in the formula. We don't know n, obviously, because that's what we're trying to find. We know that s sub n is 459. Okay, we do not know this, so it's going to stay as a variable. And we do know that a sub 1, they're telling us that's 11, and they're telling us that the last term, a sub n, is 91. Now all we have to do is combine these. 11 plus 91 is 102, and then we can cancel this. 2 goes into itself once, it goes into 102 51 times. So we're left with 459 equals 51n. And then if you divide both sides by 51, you would get n is equal to 9. So there are 9 terms in that series right there. All right, number 12 is now moving on to geometric sequences. And we know that it's geometric because they're talking about, instead of common difference, they're talking about common ratio. So all we have to do again is plug things in. So let's start with a common ratio. We can just take one term divided by a term before it. 12 divided by negative 4 is negative 3. Negative 36 divided by 12 is also negative 3, so clearly the common ratio is negative 3. So our nth term is going to be a sub n equals the first term, which is negative 4, times the common ratio, which we found, that's negative 3, raised to the n minus 1. And we can now use that formula to find any term at all in that sequence. All right, number 13 and following are also going to be on geometric sequences. So we are given a term and the common ratio. We again have to find this formula. So a sub n is going to equal, well, we know the common ratio is negative 2. We don't know the first term though. Okay, so we don't know the first term. So how can we find the first term? We can use the information they're giving us right here. Let's plug in a sub 3, which by the way is equal to negative 8. So negative 8 is equal to, we still don't know the first term. We know r. And we now know, based on this n minus 1, we know that's because we're using a sub 3, we know that n minus 1, for a sub 3, n is equal to 3. So 3 minus 1, that would become 2. So now we just have to solve this. So we still have this negative 8, and that's equal to negative 2 squared is positive 4 times a sub 1. And we can divide both sides by 4, and we'll get negative 2 is equal to a sub 1. So now all we have to do is plug that in right there as negative 2. So let me just write that a little bit neater. Our final answer is a sub n equals negative 2 times the common ratio, by coincidence, is also negative 2. It doesn't have to be, to the n minus 1. There's our formula. All right, number 14. Number 14, we have all these missing terms, so we have to figure out what distance are we traveling. What did we ultimately multiply by from negative 2 to negative 2048? We could just divide those right there. And when you divide negative 2048 divided by negative 2, you get 1024. So let's see how many times we multiplied by the common ratio. We did 1 time, 2 times, 3, 4. We multiplied by the common ratio 5 times to get to 2048. So a faster way of writing times r times r times r 5 times is r to the 5th power equals 1024. Now we can find r by taking the 5th root. And just to recall how to do that in the calculator, you would put a 5 right here. And then after putting 5, you go to math. You hit the math button, and it's number 5 right here because we are taking, in this case, the 5th root. So we take the 5th root of 1024. This should be equal to 4. And it's off screen, so let me just move it. You can see it is equal to positive 4. Okay, so that is our common ratio. So whatever we do to one side, the 5th root we have to take on the other side. So r is equal to 4. So now to fill these in, all we have to do is multiply each of these by 4 down the line. And if we do this correctly, we should end up exactly on that number at the end. So negative 2 times 4 is negative 8, times 4 is negative 32, times 4 negative 128, times 4 negative 512, and negative 512 times 4 does in fact equal 2048. So that is how those are called geometric means, by the way, when you're finding the missing terms like that. All right, number 15, we have to evaluate a series, and here's our formulas for series. We can use either one. So if you look at number 15, they're giving us a sub 1, they're giving us r, they're giving us n, so this one right here would be the easiest formula to use. So let's type this in. So S sub 7, because n is the number of terms, there are 7 terms in this series, is equal to our first term, negative 3. Again, I'm using this formula and just plugging things in. Negative 3 times 1 minus r, which is 4, to the n power. So n in this case is 7, over 1 minus r again, so 1 minus 4. So we have negative 3 times 1 minus 4 on the bottom is negative 3. And the top is 1 minus 4 to the 7th power is, I believe, 16,384. So we can cancel this negative 3 and that negative 3, and we're just left with that, which is negative 16,383, and that is the sum of that series. All right, number 16 is the same question, but this time in sigma notation. Okay, it doesn't matter which formula we use right here, but let's practice using the second one, which is this one. It will give us the same answer. So this second formula, we need the first and the last term, and we need r. Okay, r is this number. The number that's being raised to the power, that's your r. To get the first term, to get a sub 1, we have to plug in this bottom number right here, m equals 1. So let's do that. And then all we also need would be the last term, which is going to come from plugging in that. So a sub, it would be the 8th term. We'll get that from plugging in m equals 8. So if we plug in 1 right here, we have 2 times negative 6 to the, I'm plugging in 1, so 1 minus 1 is 0. Anything to the 0 is equal to 1. So we have 2 times 1, that just equals 2. And we have a bunch of other terms, and then we get out to the 8th term. So now we'll plug in 8 to this right here. So then we have 2 times negative 6 to the 8 minus 1. Again, that's being plugged in right here. 8 minus 1 is 7. Okay, so 2 times negative 6 to the 7th, that's a big number. Let me think about what that is. 276, just trying to do some mental math here. I believe that's 279,936. I'm going to kind of cheat here. Not that it's cheating if you use a calculator, but I prefer not to use one whenever it can be avoided. So I will just double check on that. I believe it's 279,936. So let's take a look. So I'm plugging this in off screen. It is good. Lucky guess. All right. So 279,936, and then we multiply that by 2, and that comes out to be 559,872. All right. So now we can use this formula right here. So the sum of our n is 8 because we're going from 1 to 8. So the sum of our 8 terms is going to be the first term, which we found out was 2, minus our last term, which we found out was this enormous number. And sometimes people are confused or worried, like, am I supposed to be getting numbers that are that large? In these types of problems, the answer is yes. And then r is, we said, is this number, negative 6. And then it's over 1 minus r, so 1 minus negative 6, which is like plus 6. Now all we have to do is simplify that, and if we do this correctly, we should get an integer. There shouldn't be any decimals because we're adding a bunch of integers. So these, when you multiply them, it's going to be a negative times another negative will be a positive. So we're going to have 2 plus, and then that's a huge number. What is that? 354 plus 48. So that's going to be 3588. So 9, and then 430. I'm just trying to do some mental math here. Again, I'm going to cheat once more and use the calculator. I don't mean to say literally that you're cheating, obviously. It's just I think it's good practice whenever possible to do these using good old-fashioned math. That is right, so I checked it. And then 1 plus 6 is 7. So if you add this top right here, you have 3,359,234 divided by 7. And that, when you do that, it turns out to be, actually there might be a mistake right here because we're not coming up with a whole number. Oh, you know what I see what the mistake was? A negative number to the 7th power, this is going to be actually negative right there. So let's fix that. So this is going to be minus, there should be a negative here, so that's like a plus. So this turns out you have a positive number here. Sorry, this is getting messy, so let me clean this up so you can see it better. So yeah, at the start of the problem, up top we had negative 6 to the 7th power, and that's going to be a negative number, not a positive. So now we have 2, and then going back to this formula right here, it's 2 minus a sub n, so minus a negative 559,000, and then we still have times the negative 6. a negative times a negative times a negative will give us a negative right here instead. Okay, so this should actually be negative right here, and then 2 minus that is going to be negative. This becomes negative 3359230. Okay, so this should now give us a correct result. So let's just double check that, and when you do that, you do get a integer number, which is negative 479,890 for our answer. All right, number 17, determine the number of terms in each series. So that's either of these formulas. Once again, we'll just use the first one because that's a little bit more direct. So S sub n is this right here, negative 46.5. That's equal to A sub 1, which is negative 1.5, times, and then this big parentheses, times, and then R is 2. So 1 minus R is 1 minus 2, and then 1 minus 2 to the, and then we don't know what n is. Okay, now we can start to simplify this. Let me just move this over a little bit so we have some more space. All right, so we have, let's divide everything by this number first. So that will help us simplify things a little. So that negative 46.5 divided by negative 1.5, that's going to equal positive 31. And then 1 minus 2 is equal to negative 1. So we have, on the bottom, we have a negative 1. On the top, we have 1 minus 2 to the n. Okay, then we can multiply both sides by negative 1. That will cause the denominator to disappear. So multiply by negative 1. That will cancel. This times negative 1 gives us negative 31. 1 minus 2 to the n. And then a couple more things we have to do. Let's subtract the 1 from both sides. So we get negative 32 equals negative 2 to the n. And negative 2 to the n is like negative 1 times 2 to the n, because you could rewrite this as plus negative. So it's like negative 1 is getting multiplied by that, so we actually have to divide by negative 1. And so we'll get this now. We'll get positive 32 equals 2 to the n. 2 to the what power equals 32? And the answer is 2 to the 5th power. Okay, so you could do logarithms to do that, but it's probably easier to just test out a couple numbers to raise 2 to, and you'll get to 32 pretty quick. All right, the last one for this video would be number 18, evaluate the series. So again, we can use either of these formulas, but I can tell you that the easier one to use will be, in this case, the second one. And why is that? Because they're giving us A1, A sub n, and R. So let's just plug that stuff in. So A sub 1 is going to be, according to this, 4, minus the last term is this enormous number. And again, that's normal because we're using exponents in these problems, and exponents tend to make things grow quickly, times negative 6. And then we have over 1 minus r, which again is 1 minus negative 6. So very similar to problem on the other page. I think negative 6 was also our common ratio there. Minus negative 6 is like plus 6, which is 7. And then here you have a negative times a negative, so that's going to be 4 positive, 4 plus. 6 times that number is, what is that? That's 1080. Let me just do this real quick. So 600,000 plus 516, I believe it's going to be this, plus 36, so that's 744. Is this right? I'm going to double check again with the calculator. So 6 times 1, 86624, and that does give us 1,119,744. When you add these together, you get 1,119,748. And when you divide that by 7, you come out with a nice even 159,000. I shouldn't say nice even. That's still a pretty large number, but you get that number, 159,964.